Welcome, everyone, to What's Happening, a weekly podcast bringing you Bitcoin mining and mining-related content. I'm your host, Cassie Clifton, and it's great to have you here today. It's Friday, Bitcoin's up, so there's definitely no complaints on my end. Before we get started, I wanted to plug the upcoming Bitcoin 2020 event. There's truly something for every Bitcoiner at this event, whether you're a seasoned veteran or you've just joined the community. Come for the keynotes and stay for the all-day party on the rooftop, art gallery, networking lounge, and lightning-enabled arcade and gaming area. If you missed Edward Snowden's keynote last year, there will be some equally amazing speakers this year, including Nick Szabo and Tony Hawk. I don't know, maybe we'll even get a little half-pipe action. And of course, there's going to be a ton of representation from the mining community there. Just to name a few from last year, Brains, F2Pool, Blockstream, Innosilicon, and Antminer, among others. So I'd love to see all of you in San Francisco on March 27th and 28th for Bitcoin 2020. In fact, I've already gone ahead and made a 20% discount code for everyone. So tickets are only $200 right now, making it already one of the most affordable and accessible events in the industry. If you pay in fiat, you can use my code CASS20, that's all caps CASS20 for 20% off. Or you can pay in Bitcoin and receive $50 off. But if you prefer to haul your sats, then you can use my code. And maybe I'll get a bonus or something like that. You can find the event link and discount code in the episode description. All right, so back to the episode. Today I had the pleasure of interviewing Chase Blackmon, co-founder and CTO of Immersion Systems. The story behind Immersion's founding was super interesting. Chase originally developed an immersion cooling solution out of necessity for his own mining facility because of the hot and humid Texas climate that was forcing them to go offline during the summers. So both he and the engineering company that he'd hired failed to find an air-cooled solution to keep the machines below their max operating temperatures. So then he decided to find an alternative on his own, went to the local Target and just picked up some materials and started building a cooling system. He didn't originally intend to take this product to market, but his peers in the mining community had such strong interest in the cooling solution he'd created that he spun up Immersion Systems. Given that we're discussing immersion cooling technology, its advantages over traditional air cooling, and the process of Chase building out and retrofitting his own immersion cooling system for his machines, the episode does get pretty technical as we're diving into some of the heat transfer and electrical concepts that are employed across the mining space. But you'll also get to hear about the Bitcoin ransom note at Chase's former company that introduced him to Bitcoin, the role of immersion cooling technology in mining decentralization, Chase's employment of hackers to exploit his miners' firmware and gain SSH and API access, which you may also know as the S17 Exploit, and a little-known ecological disaster that occurred in West Texas. Chase, it's really great to have you on today. How are you doing?
I'm great. Thanks for having me.
Awesome. Yeah, of course. So before we dive into things and get started talking about immersion and the product that you guys have built, would love to hear a little bit more about your background, what you did before this, and then kind of your transition into Bitcoin and then mining more specifically.
Yeah, sure. So before we started Immersion Systems, we ran a mining company. And during and before the mining company, I worked at our family business called BMS Catastrophe. It was a disaster recovery company. So think about fires and floods and hurricanes and tornadoes and all those bad things. It was our job to go after those events and basically clean everything up. And then
that was the largest disaster relief company in the nation, correct?
Second. So there was one more who was larger than us, but
are you able to name some of the disasters that you worked on?
Oh yeah, absolutely. So we worked on a lot of buildings that were surrounding the World Trade Center. Obviously, it wasn't a lot to try to recover from the World Trade Center itself, but whenever the buildings collapsed, they basically shattered all the windows in like a 2-mile radius, and all that concrete dust was covering all the flat surfaces in the surrounding buildings, about 2 inches on every flat surface. Yeah, so that was
I did not realize that at all.
Yeah, it was pretty crazy. We also worked at the Pentagon after 9/11. That was interesting because it was pretty top secret, as I'm sure you could imagine.
Right.
And of course, anything like with Hurricane Katrina, we did a ton of work down there. We've recovered and did reconstruction at hydroelectric power plants, and we've done all sorts of cool things. But those are some of the larger projects that we've worked on.
So that's interesting. Had you ever considered maybe like mining in Canada or somewhere near a hydro source?
Absolutely.
Yeah, I would imagine, but you're in Texas, so.
I know. If I could have done it all over again, I probably would have found myself near hydro and somewhere cold. But back when we first started mining, we were a little naive on some of those things. So
Yeah, it's definitely a learning process. That's for sure.
okay.
So you mentioned family businesses. Are you still associated with the business at all or involved in some way, or have you kind of moved on into mining specifically and strictly?
So we have completely moved on. We sold BMS Cat in October. I think it was October 1st, 2019 was the actual close date. And so we moved over from BMS Cat over to where our actual mining facility is, and that's where our office is now. And this is also where we operate Immersion Systems out of. So,
Okay. So you guys, your office is like in your facility more or less?
It is.
Okay,
yeah.
cool.
So, yeah, it's like 11,000 square feet, of which we need 200 square feet for mining, and the rest of it is basically office and warehouse space.
200 square feet? That's it?
Yeah.
Wow.
Mine's
Okay.
very small, especially when you do it in immersion. It's very, very dense.
More of like a product demo type setup?
Pretty much, yeah.
Yeah. So leaving BMS, how did you get into Bitcoin and mining?
Well, I don't really love telling this story because it kind of starts off as a negative, but it does kind of paint an interesting picture. So it was either late 2015 or kind of early 2016, and we got we got a ransomware virus on our servers at BMS, and it cryptographically locked up all of our files on the server. And that's really important because that's where we stored all of our legal contracts, all of our documents for the past decade of
With
doing
top
business.
secret clearance to the Pentagon, yeah.
Yeah, exactly. So that was a big problem. And so when you tried to open the file, you get a text file with a skull and crossbones on it and said, haha, you have been, you've been attacked or whatever. So what you have to do is send 2 Bitcoin to this address, and in the transaction, only 2.
Hackers have increased that pretty steeply these days.
Oh, I'm sure. I mean, back in the day, it was like $800 at the time.
Mm-hmm.
In the instructions, it said, in the header, make sure and put your email address for the transaction, so that way we can email you the instructions to unlock all your files. So we thought about like going to the authorities and seeing if we could get them to help us. But we're like, you know what? For $1,600, let's just try this first and see if this is like an honest hacker. And so at the time, we had no idea what Bitcoin was really. So Cameron and I, my brother and business partner, we did some research about like, what is Bitcoin? We went on, made a Coinbase account, bought some Bitcoin, sent it to the hacker. And sure enough, it was after like 3 confirmations or something, we got an email back with the unlock code. And so we unlocked all the files, like, that was actually kind of cool, even though it was terrifying.
Yeah, it definitely catches your interest.
Yeah, no doubt.
Maybe there's hackers out there who are just hacking into systems and requiring that people send them Bitcoin so that they get onboarded into the space.
Yes, the white knights of the dark
right.
web.
It's like a mix of white and black hat.
Yeah, so that piqued our interest about Bitcoin. So we kind of started looking into it, and my brother started doing some trading. From Coinbase and all the other various exchanges. But I was never really interested in trading. So I was looking like, how can I get involved in this space, but not have to watch charts all day? And found out that you can mine it. So even back, then you basically had to have ASICs to mine Bitcoin. So I had never heard of Bitmain. I was like, I don't want to send money to, some company I'd never heard of in China, then wait several months to get a machine and see how that works. So we ended up building some GPU miners to mine Ethereum, and that worked out really well. So we built 80 GPUs worth of Ethereum mining rigs.
So you built your own GPU rigs. How did you have the technical and expertise and know how to do so? I've been a nerd my whole life, probably. That's the best way to put it. So I've always built my own computers, and I think I built my first computer when I was about 10 years old. So you were like an Edward Snowden type?
No, gosh, no, not to that level. I am, when it comes to like all things actually most things in life. I am jack of all trades, master of none. There's always somebody who's better at it than me, but that's, when it comes
But
to
you're
building
curious and you go for it.
Yeah. Oh, yeah. I have
Yeah.
no worries. I'm not afraid to try anything.
Well, that's really cool.
So built those, and then that was going well. I was like, well, maybe we should try to buy one ASIC and see what that's like. So we bought one S9, and it came, 2 months later or whatever. We plugged it in, and then the next day we saw the profits from it. We're like, oh, we need a lot more of these. So we ended up, shelling out a bunch of cash to buy. We ended up with roughly at the peak at the time with 650 S9s. And
that first S9 that you bought, did you buy it? You bought it from Bitmain directly, or did you buy it resale?
Straight from Bitmain.
Straight from Bitmain. I was going to say they might not have been on resale then, but
yeah, I don't know. The space wasn't really all that refined back then. Like that didn't seem to, as far as I could tell, there weren't a bunch of folks doing reselling and.
That's what I was thinking. Yeah, that probably didn't really exist.
And if it did, it was, kind of a tighter network back then. There've been a lot more folks getting into it.
Right. You had to have been doing it for a little while at that point, and maybe located near other people who were doing so too.
Exactly.
So I guess then in that sense, what year was that you said that you bought your first ASIC?
It was probably like early 2017.
Okay.
Maybe like March or April, something like that.
Would you say that you were one of the first miners in Texas, or do you think, I know there's several others that are located there as well, and it's become pretty popular, but as far as like the first movers and shakers in Texas?
Good question. I honestly don't know. Most miners aren't real forthcoming with where their mines are. So we're a little bit different in that fact that, we let folks come to our mine and tour the facility and stuff like that. But it's mostly because they're interested in seeing like, does immersion actually work? And they want to see it working in action before they buy anything. But as far as I know, like in the greater DFW area, I'm the only person I know who is actually mining.
Yeah, I'm not sure exactly where everyone is located. I know within probably a 2.5 mile radius of you guys. So there's a number of other facilities, but.
Oh, I'm sure.
Yeah. So kind of diving into the immersion cooling side of things. As far as your product, you're really only in the business of immersion cooling, right? You're not doing any sort of hardware resale or software, correct?
Right. Yeah. For the most part, we do have an option for our customers to not buy, but to have the S17 firmware installed for them, kind of as a service agreement. And what's nice about that is that you don't have to put little fan emulators on your S17s to get them to work in immersion, and you can overclock the snot out of them, while keeping them cool. So the S17s they're beasts in immersion. You can really crank those things up.
Yeah, fan emulators. That's something I hadn't thought of, but that makes a lot of sense. But before we dive into the specifics of your product, in general for heat management in a traditional air-cooled data center, what would you say are the greatest inefficiencies?
I would say all of either the exhaust fans or intake fans or both. They're quite power hungry, and you really have to move a ton of air in these large mining facilities, especially if you're not already in a really, really cold climate. Once it gets to be about 70 degrees Fahrenheit outside, you're spending a lot of money electricity-wise on these intake and exhaust fans. And that right there, whenever we switched our mine from air to immersion, we saved, it was 30% of our power bill was all the fans to keep the mine cool. And then we saved a bunch of other, a bunch more money on the actual minor efficiency gains themselves. So we can get into that later. So I'd say for the most part, the big fans, those take up a lot of energy that no one really thinks about when they're building out a mine.
So when you started mining on ASIC rigs, is noting the inefficiencies of air-cooled systems, is that kind of what led you to create and develop your product?
Not really,
No?
to be honest. Really? Yeah. So 2017 it was starting to heat up. It was probably like, May and then June. And we were like, whoa, these things are getting real hot, starting to reach their, thermal cutoff zone. And so we did what probably everybody would do. They shove a bunch more fans on them, trying to keep them cool, trying to get all the hot air out and stuff like that. And that was not really having much of an effect. So we reached out to some engineers to see, like an engineering firm, to see if they could come up with a better solution for us. And, first they recommended air conditioning. Like, absolutely not. Air conditioning and mining do not go hand in hand at all. Super expensive. And then like upfront, and then the operating cost is just ridiculous. And then, what if we put in just insane amounts of airflow? Well, those fans are really expensive, and the operating cost is also very high. And we weren't guaranteed that would actually keep them below their max operating temperature. And we're like, man, what are we going to do? So I started, Googling, as most people would probably do, trying to research something. And I remembered seeing a immersion cooled fish tank PC from Linus Tech Tips back, like, I don't know, 7 to 10 years ago or something. It was like when Linus Tech Tips was still a tiny little, channel.
Yeah.
And,
wow. Good memory.
Yeah. Well, I know. And they built this really cool, high-end gaming PC in this fish tank full of mineral oil. I was like, if I could just scale that up, we might have a solution here. So first I posed that to the engineers, and they're like, whoa, this is, we don't even know where to begin with this. I was like, oh man, all right, well, I am not afraid to take a challenge, so I will try it myself. Sorry, do you have a question?
Yeah, were they mechanical engineers?
Yes. And I mean, it was like an engineering firm, right? So they had mechanical engineers, electrical, yada, yada.
Yeah. It's funny how you develop that one specialty and then like something foreign is thrown in the mix and you're like, I don't know what to do.
I know. I feel you. That's like when people ask me to do two-phase cooling. I'm like, oh man, it's not my thing. Maybe one day. Once the power density gets a little bit higher than it is right now, then we might start to consider two-phase cooling. But for now, single-phase cooling seems to be the sweet spot of upfront cost and efficiency. So I literally went to Target and bought a 25-gallon plastic tote, bought a water hose, cut it in half, made an intake loop and exhaust loop, bought a cheap, like 1/25th horsepower pump and a Ford Expedition radiator, tied all that together, dropped a miner in it. And well, at first it didn't work because I had to figure out how to trick the fans into trick the miner into believing the fans still existed.
The emulator, yeah.
Yeah, so I figured out how to do the emulator. That was we don't have to go down that rabbit hole, but it's actually kind of interesting how it works. I
would be curious to learn more. But
oh, okay, sure. So the controller that's on the miner itself, it sends a PWM signal to the fan saying, I want you to go at this speed, like run this many RPMs. And then the fan sends back a signal to the controller saying, hey, I got it. I am actually running at this RPM, because it takes a little bit to ramp up and ramp down depending on what the controller sends. So the controller is expecting a signal back from a fan saying, I am going so fast, so many RPMs. And it's basically an on-off signal. So ones and zeros, right? On-off, on-off.
Right. That's what I was thinking, binary, some ladder logic in there.
Mm-hmm. So it is what I did was I found a pulse wave modulation timer, basically. Like it's also, if you Google it, it's a...
we use a lot of those in my labs.
Seriously?
Uh-huh. Yeah. So for engineering, we have to. So, we did a lot of ladder logic, but we did more so with like pipes and opening valves and whatnot, and depending on like what the pressure was. So,
Okay.
Similar concept, just a different application.
For sure. Yeah. So like this would also work for a motor, right? Like tell the motor how fast to go and stuff like that. But
exactly.
You put this little chip on there, set it to be, something that's relative to, 5,000 RPM on the fan. And so the controller is like, oh, fantastic. You're going at 5,000 RPM, even though there's no fan attached. So that was interesting, trying to figure that out. So we put those on and the miner started working, and it was super cold and we started doing power measurements on it. We're like, wow, this is using a lot less power than it was when it was on air. Did a bunch of side-by-side testing, like, whoa, this is like a 25% energy savings just from one being cold and two not having any of the fans attached. This is pretty cool. Fast forward, probably a month or two, we have iterated on that design a couple different times. We made a tank that could fit 6 miners in there. That worked great. Then we made an aluminum tank that could fit 6 miners, and that was going well. And when it came time to actually put it into practice and do a full-scale immersion mine, I was doing the economics on it, and it, with mineral oil at least, the economics did not work out.
In what sense?
Let me explain that for a second. So, yeah, the thermal capacity of mineral oil is way better than air, but still not that great. Whenever it absorbs heat, and then as it goes through either the radiator or dry cooler, as it dispels its heat, it just doesn't do it very efficiently. Certainly not as well as like water would, for example.
Yeah, I want to. Air is like 1, right? Like trying to remember the exact units, but like I remember in terms of like coefficient,
right.
you'd use air is 1, right? I think mineral oil was like 0.86 or something like that. Is that right?
I think mineral oil is a lot lower than that. I was going to say somewhere like in the 0.4s, but that's off the top of my head. I could be wrong. I should look that up actually.
Yeah, now I'm curious.
Anyway, I know, me too. I'm like,
it was a long time ago for both of us.
I'm sure I have that written down somewhere.
Right.
But so I started looking for better fluids and looked at 3M, for the two-phase stuff. I was like, whoa, that is expensive. And then I found a company called Engineered Fluids, which, by the way, those are great guys. Shout out to the Engineered Fluids team. They make great products. And we got 25 gallons of a fluid of theirs called ElectroCool. And it was really nice. Like we swapped out the mineral oil in the 6 miner aluminum tank, which we now actually still have. It's called our test tank. And it was night and day. I mean, the miners were so much cooler. They actually were even consuming less power. And the only problem was that it was a little expensive. I was like, man, if I plug this into my model, it's still making building out an immersion mine too expensive. So I wrote their CEO an email and said, hey, my name's Chase, and I am just wondering if you guys would be interested in making a fluid that is less expensive, specifically for cryptocurrency miners. Everything that's going to be going into this tank is an ASIC. It's made out of like just a couple different components. So we don't need this wide swath of material compatibility that you have for servers and GPUs from every single brand, all around the world, like ElectroCool has. So if you could find some way to make this fluid less expensive on your end that still works for these types of miners, then I'll be your first customer. No response for like 3 months. I was like, oh man.
Oh, that's so disheartening.
I know. But then out of the blue, I got an email from their president and CEO, Gary Testa, awesome guy. And he's like, hey, we loved your idea. In fact, we loved it so much, we went ahead and made some. I'm going to ship you 25 gallons of it, and I want you to test it for me. I was like,
wow.
Fantastic.
Literally the best possible outcome. So like, not only did you ask and he didn't respond, but in the meantime, he immediately started working on it and developed the products.
For sure. Cool. And then we got some for free, which was awesome.
Yeah.
So we swapped out the ElectroCool with the BitCool, and the properties went down. The thermal properties went down a tiny bit. But the cost of BitCool was like 1/10 of the cost of ElectroCool. So I plugged that into my models, and I was like, yes, finally, we have something with a good thermal capacity. So we don't need, tons and tons of dry coolers and radiators to make this system work. We only need like one. As opposed to mineral oil, I would have needed, I think it was like 4 times as many dry coolers to get the same cooling effect as I would with BitCool. And those dry coolers are way more expensive than the delta between the cost of mineral oil and BitCool. So those economics worked out. And talked to my brother about it, and we were like, okay, I think we don't really have much choice. If we plan to make it through the summer, we got to do something. And We didn't quite make it in time, right? Like it was probably September or October by the time we actually got our immersion system up and running in 2017.
So then did you shut the mine down in the meantime, like during the summer?
Pretty much.
What I
Yeah.
was going to say, because otherwise you really kind of just, the equipment's taking a beating.
Yep. I think what I actually ended up doing was I got the Bitmain stock firmware that had the frequency set to 500 megahertz, and which is pretty low for an S9, but they were able to operate. So they weren't like thermal throttling and shutting down and rebooting and going through that hot cold cycle, which just destroys equipment.
Mm-hmm.
So they were just running it, I don't know, 10 terahashes, something like that, to make it through the summer. But that's pretty much the whole story. I guess there's a little bit more, but I'll let you prompt me.
Yeah. So I am curious to know. So you mentioned like summertime in Texas for these rigs, which obviously like it made a lot of sense in this scenario. Like it's super hot outside and you need an alternative method to cool your machines. But what about for like in Siberia, for example? Like how would this improve efficiencies, if it would, of like a mining facility in Siberia or somewhere else that's like really cold?
Yeah. So immersion makes less economic sense in a super cold climate like that, but it still has a lot of positive aspects to it as well. So if you're not super concerned about keeping your rigs cold, or actually I would imagine in a super cold climate you're more worried about keeping them warm than you are cold, but there are other things as well. So whenever you start to get into a good size mining facility, if you're running on air, there's a significant amount of maintenance that goes into maintaining a facility, as far as either changing the air filters for the intake, or cleaning out the miners themselves because they got some gunk in there.
I was going to say, yeah, there would probably be a lot of particles in the air.
Mm-hmm.
That could just warp the motherboard.
Yeah. So one thing immersion does is it makes your mind pretty much set and forget. Like you set it up once, turn everything on, get it tuned to the way you want it to be, and then you don't really have to go back. You can do most of it remotely. The only maintenance there really is to change every, I guess depending on how clean your facility is, every 4 months to 8 months to change out the oil filter. It's just a little particulate filter, and then it absorbs any water vapor that gets into the fluid. So you got to change that every 4 to 8 months, depending on how dirty your facility is, and that's pretty much it.
Yeah. So I mean, even just from like a time value of money standpoint, there's obviously like a lot of value add there.
Oh, for sure. Yeah, like I would say most air mines for 10 megawatts, they say they need between like 6 and 7 employees for like maintenance to constantly handle just maintenance, I guess, on the facility itself. But for an immersion mine at 10 megawatts, you need 1 employee. So operating cost savings there is pretty darn significant.
Yeah, I've always found that wild, like needing 6 to 7 employees, and then you think about like maybe like a high rise that's like 32 floors, and then there's like 1 building engineer for the entire building. So I'm like, it's such an interesting space. I would love to learn a little bit more about like the technical specifics of the product itself and how it works. Like, what is the design and orientation of the mining rigs, and like how is the cooling liquid flowing?
Sure. So it is a closed loop system, in single loop system. So as opposed to having, if you're familiar with how most dry coolers work, that usually you have a dry cooler that's sitting outside of the facility, and the fluid that's flowing through it is actually not the process fluid, meaning the one that's getting touching the heat source. So it's usually water glycol. A mixture of water and glycol to try to help prevent freezing, and so you don't have to perform a lot of water treatment on the water itself. And that goes to a plate heat exchanger or a shell and tube heat exchanger that makes contact with the process fluid. So in this example, even though we don't ever do this, it would be BitCool on the other side. So it would be water glycol to whatever fluid that you're trying to cool on the inside of the facility. So that has a host of issues that we can go down that rabbit hole in a little bit. But what we do instead is we actually put the process fluid, which in our case is BitCool, we put it through the dry cooler because it has fantastic properties. You really don't gain much of anything by trying to go to water glycol through the dry cooler because BitCool has such great thermal properties. And so the hot fluid goes out to the dry cooler, runs through basically a massive radiator with fans on it. That's what a dry cooler is.
Mm-hmm.
It comes back in and it goes through a manifold that goes up to the tanks. And there's a manifold inside each tank. And it's in the very bottom of the tank. And then there is a reservoir, I guess is probably the best way to put it, underneath where the miners sit inside the tank. And it is separated by a plate. And what these plates do is they focus the cold fluid onto each of the heat sinks of the different types of miners. So we have different plates for S9s, for Antminer S17s, for What's Miner M20S, for pretty much every different miner type that's out there. And these plates are interchangeable. So if you ever have to change equipment in the future, you just take out the current plates that are in the bottom of the tank, and I think they're like $10 each or something like that. They're pretty cost effective. Take out the plates and pop a new plate in and put whatever the Antminer S20 is in its spot. But anyway, so what those plates do is that they force the fluid straight up into the intake of the miner, and as it flows across the heat sinks, it's absorbing the heat from the process, and it's aided by natural convection of the heat. And then when it reaches the very top of the surface of the fluid, it overflows into a reservoir that runs down the length of the tank, and it's a separate reservoir that collects the fluid and sends it to a return pipe that sends it into the pump, and the pump takes that hot fluid, sends it out to the dry cooler, and comes around and around and around. As far as orientation of the miners, they're typically upside down. So for air, what would normally be the intake side of the miner is now the exhaust of the miner in immersion. So you can see the lights and stuff still, Yeah,
I would imagine you're probably putting these pretty close together as well, right?
Oh, for sure. So that's one thing that we really try to optimize for our customers, and for ourselves as well. The fluid is relatively expensive, right? So you typically want to try to maximize I call them the revenue generating components into the tank. So for the S9s and stuff like that, we actually did not put the power supplies into the tanks because they're 90-something% efficient, and they don't really get hot, and they take up a lot of space. So we just put the S9 down in the fluid, and we put them right next to each other, and so this gets basically as dense as you can with having as little dead space of heat generating components in the tank as you can, because you want to save that fluid cost if at all possible.
Yeah, I was going to say greater distance means more volume of fluid that's needed, so make a lot more sense to put them close together. So you guys already have several clients, correct? Like you've done some of these installations?
We have.
Okay. So what do you feel like your clients would be comfortable changing out their own mining rigs? Like what is kind of the process for you? Because I imagine just like, creating the product itself is only half of the battle, but then you have to think about like the contracting aspect and the installation aspect. So like what are some of the things that you have to help walk them through? How hands-on are you when you're delivering this product? Like, does that vary depending on the client? Would love to just get a feel for, more of the going to market side of things with the product.
Absolutely. So it's kind of been a mix. Some folks like to, do it themselves, and some folks really want us to guide them through the whole process and basically do everything for them. And we have the capability to build a mine from the ground up, right? Like help them acquire the land, acquire the power, negotiate with the power company, build, lay the slab, build the building, do all the electrical, set up the immersion system, prep the miners for immersion, get it up and operating, and then hand it off to them. We don't currently offer any like miner management services, but maybe in the future. We're also we're talking to folks to, basically work together on that, because that's not one of our core competencies.
So maybe earlier when I asked, asked if Immersion Cooling was the only product that you offered, I should have also asked about services, because it seems like you're providing like turnkey end-to-end services for building out mining facilities for clients as well.
Yes, okay. Absolutely. So our background in disaster recovery and construction really kind of goes hand in hand with what we're doing with immersion systems. So we are agnostic as to how many of our services and products our customers choose. We can either do everything for them, or we can just give them an immersion system and ship it to them, and give them the instructional packet and say, this is what you do, and then that's it. Or we can do the whole shebang. So we leave it up to customers, and so far it's been about 50-50 as far as like our involvement in each project. Of course, I typically advise folks to at least let us be on site when they're trying to set up their immersion system, because
it's probably a good rule of thumb.
Yeah. I did have a
couple stubborn clients.
Yes, I guess the best way to put it. That didn't, like when it came to like doing the plumbing and stuff, didn't go so well. And we had like why? That's not even close to the instructions. So
was it that they did it themselves, or they contracted out the work and they weren't able to really oversee what was happening because they didn't 100% understand like what the instructions meant?
That's a good question. I wish I would know. Because the communication lines were not as open as I would have preferred.
Yeah, it didn't sound like it.
Yeah, so we get to hear about it after the fact. Like, whoa, you've blown through most of your plumbing so far. Okay, well, we'll see how we can help you. Like we're
here for you if you need us. Yeah,
for sure. Yeah. And so we always try to help people and do everything we can to get them up and running and operational and as efficient as they can be as well.
So as far as like on-site installation goes, do you have contract companies that you typically work with that kind of have a feel for and have gotten to know your product? Like what are the contractors that are needed? Like how many people are you kind of bringing on to oversee this installation?
So
assuming you're doing it end to end.
For sure. So like on the construction side of things, absolutely. We've worked with contractors all over the US. And so we have a big list of folks that we've worked with in the past. Now, granted, most of those folks haven't done any of the immersion systems stuff so far. But that's okay, because we would send a member of our team out there to act as the project manager, and then they would just train on site. It's honestly like setting up the system is not that complicated if you know what you're doing, but it can definitely be daunting if you've never done it before. So that's why we always recommend like at least let us come and like help your team set it up.
Right. And it's just a lot easier too. Like if the contractor has a question, it's super easy to answer it and not have to like, give you guys a phone call every single time. So,
absolutely.
Or, whoever's on site can be like, oh no, you're doing this totally wrong. Like change it.
Mm-hmm. And then when it comes to like install services and stuff like that, when they actually want us to do everything for them, it's still kind of similar in that fact where we'll send one of our project managers out to the site, and we'll hire local laborers to, and there's different labor companies you can go to, across the US, and some are better than others. And some cities have, better laborers than others, but that's something that we're used to managing. And so we'll do on-site training of how to disassemble a miner, take the fans off, how to properly seat it into the immersion tank, how to, all the different things that go into the process, and get it all set up for them. Make sure the system is tuned. Make sure they understand how to operate the valves and pumps and coolers and all that stuff. And I usually request that they set up either VPN access or TeamViewer access or something like that. So if they have a question, I can actually look at it. And we typically build a pretty good rapport with our customers. So they're comfortable with allowing me on their network, at least for a limited amount of time.
Mm-hmm.
Yeah, knowing that I'm not going to like redirect all their miners to my wallet or something, or we're a business. They know where I work. So
right, yeah. I think you'd go out of business pretty fast if you did something like that.
Exactly.
So speaking of cities, you mentioned like contracting out of different cities. What cities have you done installations in, or are you like looking forward to doing installations in the future?
So installation cities so far would be DFW, Houston, Conroe. What is the name of that city? Mount Pleasant, South Carolina, New York, and then there's a ton of projects going in West Texas that are basically like in negotiation, but we haven't closed on yet, so to speak. But I'm sure you've heard there is just a ton going on in West Texas right now with mining. So
Texas is booming. I think it'll be like the new mining mecca of the world. Definitely North America, but I think it's positioned to take over as well. Agreed.
I mean, there's all that stranded energy out there that they can't get back to the big cities and stuff. So it makes a ton of sense. The only problem they have out there is it's too darn hot, and the air is corrosive.
Yes, that's true. Especially in some of those like smaller towns that are more or less just like dust and dirt for miles.
Mm-hmm. Can I touch on that for a second? Because I found this interesting. So there was a mine out in West Texas that they knew it was going to be too hot to just run on air. So they built a water wall on one side. You basically swamp cooler pads, right? That like on the intake side. And, so they'd spray water on the swamp cooler pads. And as it evaporated and came into the facility, it would drop the temperature by 20, 25 degrees Fahrenheit, which actually does work.
Evaporative cooling. Mm-hmm.
Yeah.
We use that in Tennessee as well, but more so for like really large centers, not necessarily data, but like a Target or something might use one.
Right. The only problem was that they didn't take into account the what is basically like an ecological disaster out in West Texas, and it's really hadn't been like all over the news or anything like that, but which is shocking. Well, maybe not, because oil and gas companies, they probably trying to keep that hush hush. But anyway, so what's going on is whenever they're drilling for oil and gas, so they put a big pipe into the ground, and as they pump I think it's actually like kind of salt water down to frack the rock down there and to extract the gas and extract the oil, a ton of sulfur dioxide gets released through that pipe whenever they do that. Interesting thing about sulfur dioxide, as soon as sulfur dioxide touches a water molecule, it turns into sulfuric acid. So this mine that was in West Texas that had a water wall was basically spraying sulfuric acid all over their miners, and it died within like 9 months, like everything.
I'm assuming that like they didn't go in and like look at and see just like what the quality and standpoint of their machines was at any time in those 9 months. Because that's something that I feel like at some point you would have to realize, right? Like, 3 to 4 months in, you'd probably go in and look and be like, oh, wow, this is really corrosive. Or
yeah, it looks really rusty. I wonder what's wrong.
Right, yeah. I wonder if there's like a problem I should address or something like that.
Yeah. Is this dust? No, that's rust. Oh, no. So, yeah, I don't know. It's a good question.
That is really interesting. What town was that in Texas again, did you say?
That was Lubbock, Texas. So.
Oh, okay. Yeah. Is that near like Texas A&M?
Yes.
Okay, I thought so. Yeah, I was thinking so. I would love to, since you mentioned like end-to-end solutions, and you also mentioned kind of like pulling together different resources and like doing installations from everything from like transformers to the construction. Do you work with any other companies that are within the Bitcoin space specifically or crypto space specifically?
Yes and no. I mean, we're kind of in, we're a relatively young company, but we're growing quickly. So we're talking to a lot of the folks who are already kind of doing this sort of thing to see how we can synergize on some of these things, because we have the ability to do it ourselves, but we're still a small team, right? So some of these, like for West Texas, for example, if all of the jobs that we had in West Texas, like that are currently in the pipeline, hit at the exact same time, we're going to need some help. So we're talking to some of the folks who already do, mine installations and stuff like that to see how we can work together to make sure that we can service all of our clients effectively, and not, try to like do a rapid fire hiring session with folks that we haven't vetted, like thoroughly vetted just to get the projects going. And that would be a terrible disaster. And that would not be the kind of quality that we're looking to, provide to our customers. So we're trying to do our due diligence up front and make sure that we have partnerships in place to basically guarantee that we can fulfill our end of the bargain.
Yeah, I would imagine, because you guys are a team of 3, is that right?
So there's 4 of us.
Okay. 4 of you.
4 of us.
Yeah, I would imagine that if there were no distribution of all the projects you've got in the pipeline and they all just hit it once, it'd be really difficult for a team of 4 to manage all of that.
Oh, no doubt. Oh, yeah, we can only be in so many places at once.
Right. There's only so many hours in the day, and unfortunately, we have to sleep overnight. So,
yeah.
Kind of speaking about some partnerships, I saw on your Twitter that Bitmain had recently visited you guys for a strategy session. Are you able to talk about that at all? And you also mentioned some exciting news, which I don't know if you're allowed to say anything about, but if you can't, I understand.
I honestly don't think I can.
Okay.
I would say that we have some interesting things coming, and we are talking to hardware manufacturers about how to refine their product to work in immersion really well. There are some very simple things that could be changed on.
So you don't have to retrofit.
Yeah, for sure. On it doesn't matter whose hardware it is. Canon already has the immersion specific boards that. They work pretty darn well. I'm testing one set of those right now. But even those, the ones that were designed to be immersion specific, I'm like, man, why did you put this here? If you put it on this side, that would make way more sense. You could double the density of this thing by moving the power connector from this side to this side. The little simple stuff like that. And then trying to work with folks on like heatsink design. The heat sinks for air cooling are not optimal for immersion cooling at all. They're way too dense. They're way too tall, too many fins. So if you can make the heat sinks shorter, basically chunkier, they don't, you still need a fair amount of surface area, but not nearly as many fins. And you could really, take a S9, for example, instead of having 3 boards inside the little shell or whatever, you could easily fit 4. And so you can really just start to increase your density in each tank just by changing the heat sinks. So little simple stuff like that. I would say in general, what's interesting in the past 6 months or so, I'd say, is it seems like all the hardware manufacturers are actually talking to their customers again. I
have noticed that as well. And Bitmain's, the name is on the tip of my tongue, but the basically like the educational program where you can go over to China for like a 2-week period and get like certified, so to speak, for working on equipment. Mm-hmm.
I think they're going to do some here in the US too, here pretty soon, if I remember correctly. But yeah, no, it's interesting. The sentiment from the hardware manufacturers has really changed recently. They're talking to folks, they're taking feedback, they're reaching out and doing partnerships and stuff like that. And so it's kind of cool. I think in the crypto space, at least, we're kind of one of the only like immersion cooling companies that's really trying to do it, as opposed to like being focused on data center and just kind of dipping their toes in the crypto market. So they're, a lot of them are talking to us about immersion specific stuff, which is really fun because we can really kind of help shape the future of what, hardware looks like in immersion, which is super exciting. Yeah, no, it's definitely exciting. It's super promising for the future of the mining space overall too. I think especially with all the competition that's out there right now, and the fact that like each product competes very competitively with one another in terms of the efficiencies and output, we're in a good place. Agreed. I know that immersion cooling itself was probably like one big rabbit hole that you dove into, right? It's so deep.
Yeah. Are there any other rabbit holes, maybe like not of that intense in nature, that you've been diving into lately? Whether it be like Bitcoin or mining specific or somehow tangentially related to the space?
Firmware for the S17 has been a very interesting endeavor. You know, so while all the hardware manufacturers are being very open, like, talking with their customers again, on the other side of things, they're completely locking down their hardware, so you can't even get into it. So it's kind of a reversal a little bit on that side of things. And that's really frustrating from the miner's perspective, because they bought this hardware, right? Like, they own it, and the manufacturer has decided that they can't control it. And I'm kind of a control freak, so I always want to have my control over anything that I own. And so we got involved back when the S15 first came out with a group of guys who, they're basically hackers and pen test experts and stuff like that. And I gave them VPN access, and I was like, all right, guys, here's the deal. I need somebody to try to break into this thing and get SSH and API access back, because I can't handle not being able to control it. So
was that successful?
It was, yeah. I don't know if you ever saw it was it blew up on Twitter for a little bit at least, but it was called the Exploit, the S15 Exploit.
I did not, but I'll have to look into it.
Oh,
I'm pretty new to the Twitter space, or at least in terms of like being, more actively.
Yeah, no worries. I really do any social media whatsoever. So, but anyway, so they did it. They broke in. They got SSH and API access back, and then we've basically used that script to gain access to the S17. Once we did that, we could start to reverse engineer the firmware on the S17 to allow stuff like overclocking and disabling the fans via the firmware instead of having to put fan emulators on them and stuff like that. So the S17 in Immersion is an absolute beast. You can do 80 terahashes at 3,360 watts if you have a good unit. And
oh my gosh.
That's
so much power.
It is. But at the same time, it's still really efficient. It's about as efficient as it is like our S17 Pro 50s. They, they would run at most 58 terahashes in turbo mode. And that was for about 2,850 watts. So bumping that up to 80 terahashes for 3,360-ish watts or so. That's like the average. There's actually a pretty large range, depending on the quality of the silicone on your hardware. But that's silicone lottery. Sometimes you're going to win, sometimes you're going to lose. That's kind of the average.
Does it differ a lot from machine to machine, just like in terms of like quality control within the products coming off the line, even if they're in the same batch? Yes. That's I've heard. Yeah.
Significantly, like much more so than the S9s. The S17s, there is anywhere from like maximum overclock potential of 15 to 18 terahashes. And then as far as like the chips themselves, I mean, even on a good unit, one chip might be at being able to handle 87 terahashes, whatever those settings are. I think it's like 900 frequency and 20.2 volts. Sorry, off the top of my head here. But the other chips on that same board, they're all 7 nanometer, can barely handle 600 frequency at 19.8 volts. So even you really have to, if you're going to be like super efficient with your overclocking, winning the silicone lottery is kind of a big part of it.
I mean, it's funny too, and I feel like this is, not even just specifically to silicone, but with any sort of product that's manufactured, like mass production, it doesn't really matter what batch it comes out in. I feel like every product is still different in some way, even if it's only a little bit. Like even doing labs in college, you notice like you have to do this whole write-up on like the theoretical values that you're supposed to get, like what the outputs are, and everyone has the same input, but everyone's working on different machines, right? And so everyone's experimental values are like drastically different, and you're just like, how can this be right? This is so odd, like this is what the manufacturer says, but it's nowhere close to that. So
I know. And you would think that like the binning process would help with that a lot, but I guess that depends on the manufacturer. Like, are they really doing a thoroughly good job of binning these chips? I'm guessing not.
There's definitely a lot of iteration and refinement in that process. And I think, some of the more like legacy manufacturers that have been around for a long time have fine-tuned that process, but it certainly takes time.
Yeah, no doubt. I mean, like, this is not part of the crypto space, but Intel with their new, what is it, 14 nanometer plus like topology or whatever for the 9900KS, where they specifically bend, chips that are in like the high 99th percentile. And that's the only chips that they'll use in that 9900KS, right? So that you're going to get the performance that you actually are paying for from that chip.
Yeah. And I'm sure that's been a lot of time in R&D for them to, Oh
my gosh, I can only imagine.
There. Yeah. Wow. So are there any parting thoughts that you would like to share? Or anything cool that you guys have in the works, or like maybe one of your greatest takeaways from going through this process and building out this product and working with companies in the space?
In my mind, as computers get more and more dense and the nanometer technology gets smaller and smaller, and these dies are getting bigger and bigger, and there's just a lot more heat going into a smaller space. And we're seeing that in the mining space, and we're definitely seeing that in the data center space, and to an extent even in like the home PC space. When you look at the new AMD 32 core chips and stuff like that, it's getting insane. And we're starting to reach this inflection point, not only in the crypto space, but in the data center space as well, where traditional cooling systems are just not able to keep up with the extreme power density that these smaller nanometer chips are able to provide. And we've seen plenty of it, from folks who are in data center. They're having to try to ramp up their cooling capacity, and it's just costing them, billions of dollars to try to keep these data centers cool. And so I thoroughly believe that the future of large scale computing, whether that's in the mining space or the data center, is going to turn to immersion. And that's just because the thermal capacity of immersion is about 1,600 times more dense than air. And so you can just cram a ton of electronics into a really small space and keep them cool. And so we're really excited to be kind of on the forefront of what I feel like is going to be a movement if it hasn't already started. And we're really looking forward to, the next 5-10 years of what computing is going to look like. And we're going to do everything we can to make sure that we are right there in that race and winning it. So I'm looking forward to it.
Yeah, I think that is a fantastic point, and I would say definitely at the forefront for this industry. But I mean, even for the data center space at large too, because I want to say it's like less than 20% or so are immersion cooled. I'm not sure exactly what the figure is off the top of my head, but that's something that a trend that we've definitely been seeing, but it hasn't like fully taken hold yet and become like widely adopted. Right. So it's super important in that sense, but also in terms of energy efficiency. I mean, if you look at like your typical building, like an office building, let's say, 35% of the load, the electricity load, that consumption comes from HVAC systems. So when you think about in the data center space, you're using significantly more energy. And let's say like in a commercial building, you're using 35% for the HVAC load. Well, it's significantly higher in a data center. And so just in terms of, energy management, as well as like lowering our carbon footprint, I think that's going to be really important going forward.
Absolutely. I couldn't agree more. The PUE that they get in these, high density data centers is really bad. And that's one of the metrics that you look for in a data center is like, all right, what's your low PUE? And we've been able to achieve PUEs as low as 1.03 and below, which is pretty darn good, especially considering that we're doing mining equipment, which is just incredibly dense, right? Like way more so than data center.
To provide a little context there, what would you say like standard PUEs for a data center?
Oh gosh, that's a good question. I think it's 1.1, or I think it's usually, if you're at like 1.1 and below, I think you're pretty good. But with the density that these like new servers and stuff that are putting out, I think they're starting to creep up in the 1.3, 1.4 range.
Oh my goodness! Wow.
Wait, I'm sorry. 1.13, 1.14. Sorry.
Okay, I was like, that was a huge jump because even you were realizing 0.07 delta, which is good, but yeah, it'd be a really big difference.
And then lastly, the one thing that I think is actually another really cool thing about immersion is that when you think about where most mines and where most data centers are located, they're, most of them try to focus in cooler climates near cheap electricity. Well, there's a ton of cheap electricity all across the world in hot climates or super humid climates where you would never consider putting a data center or mine for that matter. I think of them interchangeably, but one thing that immersion does is it opens up the rest of the world to this decentralized idea and like philosophy of like, this is a decentralized currency, even though most of the hash power is located in China, some in the United States, some in Canada. And we're starting to see places like Venezuela, come online with some pretty decent hash power. And we're talking to a lot of folks down there because it's hot and humid. So one thing that I think is really cool about immersion is it basically unlocks the rest of the world. So we can truly get to this decentralized nature as opposed to kind of how centralized it is right now.
Yeah, no, that's definitely, super, super exciting to think about how this could help push forward the decentralization of the mining space. I know that's something that is a pretty large concern, not only for the Bitcoin community, but also the miners. But finding an actionable solution and something that we can actually implement to help solve that problem is very, very cool. So, well, thank you so much, Chase, for chatting with me today. I really enjoyed talking to you. You have a very, very curious mind. I feel like you have such a very a unique background, but it is completely different from what you have found yourself currently doing. So that's really cool that you were able to connect the dots there and tie all of those interests together. Really excited to seeing what you guys do in the future and how your product takes off.
Well, thank you. I really appreciate it. It has been an interesting ride. I'll tell you that much. And
I can only imagine.
We are looking forward to the future. It's going to be a lot of fun.
Awesome. Well, thank you so much, Chase. All right. Well, that does it for this episode of What's Happening. Thanks to both Chase and to those of you listening for joining me this week. You can find Immersion Systems on Twitter at Immersion Systems. Check out the links in the show description to learn more about Immersion Systems and to buy your tickets to Bitcoin 2020. Thanks so much for tuning in, and please don't forget to subscribe to the show on iTunes, Spotify, or wherever else you get your podcasts. The What's Happening podcast is a BTC Media produced podcast on the Let's Talk Bitcoin network. It was produced and edited by Christian Corollas. Be sure to follow the show on Twitter at What's Happening, and of course my personal account at BitcoinCasts. You can find more podcasts covering Bitcoin on the Let's Talk Bitcoin network and can follow them on Twitter at the LTB network for all of the latest episodes.